In Interstellar, science and fiction converge to explore the limits of human knowledge. The film is based on theories by physicist Kip Thorne, who guaranteed the accuracy of concepts such as wormholes, hypothetical tunnels that would connect distant regions of spacetime according to Einstein's equations, although their stability would require exotic energy that is still unknown. Gravitational time dilation is also addressed. Near the black hole Gargantua, 1 hour is equivalent to 7 years on Earth, a real effect proven in extreme gravitational fields. Gargantua, moreover, was recreated with simulations based on real physics, showing how gravity bends light and creates its iconic appearance. The film also sets out the search for habitable planets, an idea supported by the discovery of thousands of exoplanets, some potentially suitable for life. The worlds visited in the plot, such as the water planet, reflect how proximity to a black hole can alter planetary conditions, something scientifically plausible. Interstellar also explores current issues such as ecological collapse and the need to migrate into space, raising troubling questions about the future of humanity. Towards the end, it introduces speculative concepts such as the fifth dimension and time travel, represented in the Tesseract where Cooper interacts with the past. These ideas derive from advanced theories about quantum gravity and higher dimensions, although they are still far from proven. Even the notion that love transcends time and space, while romantic, suggests as yet unknown physical connections. Ultimately, Interstellar is not just a visual spectacle, but a profound reflection on the mysteries of the cosmos and our ability to understand them. In Gravity, science and fiction intertwine to create a stunning viewing experience, albeit with some liberties. The film correctly portrays space as a vacuum, with no sound and microgravity keeping astronauts afloat, but it makes mistakes in presenting the proximity between the Hubble telescope, the International Space Station, and the Chinese Tiangong Station, which are actually in different orbits and separated by thousands of kilometers. Moving between them with a jetpack would be impossible. Kessler syndrome, key to the plot, is a real phenomenon. A collision between satellites or debris could trigger a devastating chain reaction, jeopardizing future space missions. Newton's laws are well represented, as when movements in zero gravity depend on action and reaction, although maneuvering with a fire extinguisher as a propellant would be extremely difficult. On the other hand, the physical endurance of astronauts is highly dramatized. Walking long space distances or enduring such high levels of stress without extreme exhaustion is unrealistic. Likewise, the massive destruction of satellites and space stations would generate a cloud of debris that would take years, even decades, to disperse. Another aspect is the re-entry into the atmosphere in the Chinese capsule, which is shown in a simplified way. In real life, any small error in the angle of entry could cause the vehicle to disintegrate. However, the film succeeds in conveying the hostility of space, where the temperature ranges from hundreds of degrees below zero in the shade to more than 100 in sunlight. It's also true that an astronaut's life depends on every tool, every calculation, and every decision. While Gravity isn't 100% scientific, it does manage to vividly capture the loneliness, vulnerability, and constant danger humans face as they explore the cosmos, reminding us that in space, even the smallest mistake can be fatal. In the 2021 film Dune, the science behind its universe not only gives depth to its narrative, but is also inspired by real concepts. Space travel depends on melange, a fictional substance that allows the bending of spacetime, an idea that finds its roots in Einstein's general relativity and wormholes theorized by quantum physics. Without this spice, ships would not be able to move across interstellar distances, a challenge that modern science still faces. The Freeman stillsuits, which recycle body water to survive in the desert, are based on current purification technologies, such as those used by NASA on the International Space Station, capable of converting sweat and urine into drinkable water. The gigantic sandworms of Arrakis, adapted to a hostile environment, reflect principles of biological evolution. In extreme ecosystems, creatures develop unique characteristics to survive, like desert animals on Earth. On the other hand, the absence of artificial intelligence, prohibited after the rebellion of the machines, raises a focus on human mental development. This concept explores the limits of the brain, which, according to neuroscience, could reach higher levels through training in chemicals that enhance cognition. The sandstorms of Arrakis, with winds of hundreds of kilometers per hour, are inspired by real storms on Mars, which, although less dense, could reach similar speeds and devastate any structure in their path. Even terraforming the planet, once referred to as a distant dream, is linked to current research into how to alter atmospheres and ecosystems on worlds like Mars or Venus. Dune is not just science fiction, it is a bridge between what we know and what we might conquer in the future, combining imagination and science in an epic tale. In Arrival, we delve into the fascinating science behind alien spacecraft visits. The heptapods, with their radial symmetry and 7 limbs, present us with a biology radically different from that of Earth, challenging our ideas about evolution and life itself. Their language, a complex system of nonlinear logograms, reveals a perception of time that deviates from our linear, sequential experience. This concept finds echo in Einstein's spacetime physics, where past, present, and future are not separate entities, but intertwine in a continuum. Interaction with this language transforms the protagonist's perception of time, allowing her to experience time in a non-sequential manner, as if her brain were adapting to the alien structure. This temporal alteration is a key point in the film, where we see how the protagonist can see the future and the past as if they were the present. The film explores the Sapir-Whorf hypothesis, which suggests that language not only describes reality, but also shapes it, influencing the way we think and perceive the world. This idea is reflected in how the protagonist changes her perception of time when learning the alien language. Furthermore, the film raises the possibility that quantum physics, with its multiple realities and timelines, could allow for a perception similar to that experienced by the protagonist. This idea invites us to reflect on the nature of reality and how our perception can be limited by our biology and our language. Arrival prompts us to reflect on how science, language, and communication can expand the boundaries of our understanding of reality, questioning our preconceived notions about time, life, and the universe. It shows us that true exploration is not limited to outer space, but is also found in the recesses of our own minds and in the possibilities of communication with the unknown. The film, at its core, is a journey through science and philosophy, a challenge to our anthropocentric view of the cosmos, inviting us to consider other perspectives and possibilities. The film also makes us think about the importance of communication and empathy, even with beings that are radically different from us. In The Martian, Mark Watney's survival depends on his scientific ingenuity, a constant struggle against the adversity of the Red Planet. The film shows us the chemistry of producing water, an essential element, using hydrazine, a highly toxic compound that must be handled with extreme caution. Electrolysis, a process that breaks down that water into hydrogen and oxygen, is crucial to generating breathable air and growing food. Hydrogen, a flammable gas, must be carefully managed to avoid explosions, a constant risk in the confined environment of the habitat. Physics comes into play when calculating the trajectories of the spacecraft, using the Earth's gravitational assist, a precise maneuver that allows reaching Mars with minimum fuel consumption, optimizing each stage of the journey. Botany becomes their ally when growing potatoes on Martian soil, a challenge that requires fertilizing the soil with its own waste, a process that involves the decomposition of organic matter and the release of essential nutrients. Precise control of temperature and humidity within the habitat is vital for plant growth, simulating terrestrial conditions. Engineering is crucial to modifying the vehicles, adapting them to the conditions of the Martian terrain, and to creating improvised communication systems using solar panels and antennas, demonstrating how science can overcome seemingly insurmountable obstacles. In addition, the film addresses the complexity of cosmic radiation in space, a constant risk for astronauts, requiring protective shields for prolonged stays, and how this radiation can damage DNA and increase the risk of cancer. All this is added to the properties of the Martian atmosphere, composed mainly of carbon dioxide, which makes breathing difficult and requires pressurized suits for activities outside the habitat, in addition to the low atmospheric pressure, which would cause bodily fluids to boil without adequate protection. The film, although fiction, presents a solid scientific basis that makes us reflect on the challenges of space exploration and the human capacity to adapt to hostile environments, using science as a fundamental tool for survival.